Okay, hello everybody. This is part 2 of the distributive law and combining like terms. So Bonnie, are you ready to learn from this lesson?
Yeah.
Okay, great. So last time we talked about numbers, um, variables, terms, and expressions. And if you don't know the difference between those, go back to part 1. All right. Now, before we talked about expressions, that they are terms added together. So for example, if you have 1 plus x plus 2y, these are each terms and you can add them together to get an expression. But in this lesson, we can talk about a different kind of term, which is also a term where you have two variables multiplied together, like xy. You can have like 3xy plus 4. You can even have x times itself, and that's written as x squared. Okay? So if you have 3xy, that's the same as writing 4x times x. This little dot is a multiplication. So these would be equal to each other. X squared is x times x. That's also a term, and so this is an expression here. Or another example is if you have 5 plus 2, you could even have like x, y, z, or a, b, c. What this is x times y times z times 2, or just a times b times c, and you could have minus 7ab. Now in this case, can I combine anything together? Well, you might think that I could combine something like the ABC with the 7ab because it's got an ab in common. But no, they're not the same kind of term. These cannot be combined because ABC cannot be combined with ab. They have to match. The whole entire term has to match in terms of the variables. So x squared can only be combined with other x squareds, and ABCs can only be combined with other ABCs. Does that make sense, Bonnie?
Yeah.
Okay, so let's try an example. What if we had negative 6 times n minus 7 plus 8 times 5 plus 6n, and we want to try to simplify this. Well, oh, sorry, I was copying from something and I wrote a minus, but I really meant plus. Thank you very much, Bonnie. Okay, so let's say we have this, and I want to simplify this expression. Well, as we discussed in the last lesson, you can't just say, let's combine this 6n with that n to get 7n. No, that doesn't work at all. What's the first step we need to do here, Bonnie?
You need to make the parentheses go away.
Make the parentheses go away. Using what law? The distributive law, right? That's how you get rid of parentheses in this case. All right, so let's get rid of the parentheses. Whoopsies, you can't just X them out. Get rid of the parentheses here, and then we get rid of the parentheses here. So in the first one, I've used the distributive law. So distributive law, sorry, sometimes I talk a little bit fast. So negative 6 times parentheses n minus 7 is negative 6n minus, well, let's see, this is a negative 6 times a negative 7, so that makes a plus 42. And then this one over here is a 40. And then how many n would I have over here, Bonnie? I've got to do 8 times 6n. So how many would that be? 48n, right. Good. And what I end up with is, well, I can combine the negative 6n with the 48n. And how many do I get there? Well, I've got to do 48 minus 6. And that's how many n's, okay? So that's 42n, that's right. And then how many numbers do I have? 42 plus 40 is 82. Okay, so that's the answer. This didn't involve any terms that have like squares or anything. So let's do another example that involves squares. Okay, so let's say we had negative 7 times 4x plus 4, and then I add 3x times 8x plus 7. Okay? Now this is going to be hard because I've got an x here and I've got an x here, and they're going to be multiplied together. See that, Bonnie?
Mm-hmm.
Okay, so if I want to simplify this, what's the first thing I need to do, Bonnie?
You need to get rid of the parentheses using the distributive law.
Wow, you learned quickly, Bonnie. Very good. Get rid of the parentheses by using the distributive law. So I got to distribute that, and then I got to distribute that. So let's see, over here I've got negative 7 times 4 is negative 28, so I got negative 28x. Negative 7 times 4 is, again, negative 28, but I don't have the x there. Then here I've got 24, and here's the tricky part. I've got 3x being multiplied by 8x, and that gives me 24 what, Bonnie?
X squared.
X squared, or x times x, right, x squared. And then I've got 3x times 7, which is plus 21x. So that brings us to the question, what terms here am I allowed to combine? Can I combine the negative 28x with anything?
You can do 21x.
21x, that's right. But I can't combine it with the 24x squared because that's a different type of term. X's can't be combined with x squareds. All right, now the negative 28 just stands by itself, so let's circle that guy with yellow. He just stands by himself. And the 24x squared also just stands by himself. They're like unique terms in this. So I just have one combination here, and I end up with negative 7x plus 24x squared minus 28. The order that you write these doesn't really matter, as long as you remember to keep the negative signs where it's appropriate. Okay, so this is the simplified expression. Should we put in a number and see if it works?
Yeah.
To check our answer? Okay, Bonnie, what number should we put? And don't pick one that's too hard.
5.
5. Okay, well, that's a high number. Not too high, but all right, let's see. Let me switch to green. Let's say that x was equal to 5 because we want to check to see if we got the right answer. All right, if I plug in 5 there, and I plug in 5 there, and I plug in 5 there, what do I get? Well, let's see. This will be 24 times negative 7. Ooh, this is a high number, Bonnie. Negative 7 times 24. And then I've got plus, let's see, that would be 15. And then times 8 times 5 is 40. So this would be 47. Whoa! We need a calculator for this. All right, so anyway, we get this negative 7 times 24, and we get 15 plus 47. It's kind of hard. Now let's go down here and see what we get. I'm not actually doing that out because I don't have a calculator. But let's say that we had plugged in 5 right there, and right there, and that's it. So then I'd have negative 35 plus 24. What's 5 squared?
10.
No, 5 squared.
25.
25, that's right. 24 times 25, and then I have minus 28. Well, for those of you watching the video, why don't you just go ahead and try. Plug this into the calculator, and then plug that into the calculator, and see if you get the same answer. I think you will. All right, let's do one other example. Let's try negative 4x times 5y minus 2 plus 7y times 1 minus x. Does that look hard? Kind of hard, because it involves 2 different variables, right? All right, let's see what we can do. First thing we do is get rid of the parentheses by using the distributive law. So when I distribute this first one here, I get, Bonnie, let's see if you can do this. What if I have negative 4x and I multiply by 5y? What do I get there? Oh, you don't know how to multiply negative numbers yet. Okay, we'll need to make a whole lesson on that. Okay, so anyway, negative 4 times 5 is negative 20. Okay, but what do I do with the x and the y? Well, they just get multiplied too. So this whole term is negative 20xy. And then negative 4x times negative 2 is positive 8x. Okay? And then over here, what I've got is 7y, because 7y times 1 is 7y. Then when I multiply by negative x, I just get negative 7yx. Now, what can I combine? Can I combine any of these terms? Are any of them the same?
Negative 20xy and negative 7y.
Yep. Now, one of them is xy, and the other is yx. Is that a problem?
No, because you can just switch them around.
No, it's not a problem. You can just switch them around because of the commutative law of multiplication, right? So xy is actually the same as yx, right? So I can combine these two, and I end up with negative 27xy plus 8x plus 7y. Is the simplified version of that first one. Isn't this funny? Not funny. Isn't this fun, Bonnie? She didn't answer. It might be fun. I know what she thinks is fun. She wants to get a hold of this tablet drawer so she can draw a picture with this, which I'll let her do after this. Anyway, so enjoy your, doing your worksheet problems.